Have you ever wondered how hundreds of digital radio stations can all be broadcasting at once without just turning into a complete, chaotic mess of sound? It turns out the airwaves are basically a massive highway system, and it has some very, very strict rules of the road. Let's get into it. So we're going to be looking at the world of DAB+ signals, and specifically, we're talking about these little parts on the side called shoulders. Now, they might not look like much, but trust me, they are absolutely critical for getting that crystal clear sound that you expect. So what exactly are they, and why are they the key to a smooth ride on the airwaves? To really get this, let's start with the big picture. I want you to think of all the radio signals flying through the air around us as cars, trucks, and buses, all driving on a huge invisible highway system. That highway system is called the radio spectrum, and it's divided up into different bands, or you could think of them as different highways. You've got highways for old school FM radio, and then you have the super highway for digital radio, the DAB+ band. And because this is a limited resource, every single broadcaster has to share the road. And on this DAB+ superhighway, every single station gets its own specific lane to drive in. It's a pretty wide lane too, exactly 1.536 megahertz across. But the most important rule of all, you have to stay in your lane. If you don't, you get total chaos. So what does a perfectly behaved signal, let's call it a perfect driver, what does that actually look like in a perfect world? Well, in a perfect theoretical world, a digital radio signal would look exactly like this. Just look at how clean those edges are. It's kind of like a big truck parked perfectly between the lines, taking up its assigned space and absolutely nothing more. It's neat, it's tidy, and it doesn't bother any of its neighbors. Yeah, that's the theory. But as we all know, the real world is, well, it's always a little bit messier. And this is where we finally meet the star of our show, the signal shoulders. This is that unavoidable spillage that happens with any real-world broadcast. Okay, so on the left, there's that perfect signal, all contained in its channel. But on the right, that's reality. The main signal is right there in the middle, but on either side, the energy doesn't just stop. It sort of trails off, and that's what creates these shoulders. It's just like a truck that's a bit too wide, with its tires starting to creep into the next lane over. And those shoulders, that spillage, well, they cause interference. It's basically the audio version of a traffic jam. If one station's shoulders are too big, they bleed into the next lane, causing static and noise for anyone trying to listen to that other station. So how do engineers stop this from happening? How do they keep every single truck perfectly in its lane and avoid these massive radio traffic jams? Well, it all comes down to a set of pretty high-tech rules. They use something called a spectrum mask. This is the master rulebook. So if the radio channel is the lane on the highway, the spectrum mask is the set of solid white lines painted on the road. It's a really strict power limit that basically tells the signal you are absolutely not allowed to cross this line, period. And, just like on a real highway, the rules can change depending on how much traffic there is. In a really crowded city with stations packed right next to each other, engineers use what's called a tight mask. Think of that as very strict, very narrow lines. But out in a rural area with fewer stations, they can use a loose mask, which gives the signal a little more room to breathe. So how do they enforce all these rules? With incredibly sophisticated electronics. Now, you really don't need to understand every single box on this diagram. Just think of all of it as a super advanced, high-tech, self-correcting steering system. It is constantly monitoring the signal and making tiny little adjustments to keep it perfectly centered with its shoulders tucked in right where they should be. Okay, so this is all pretty fascinating from an engineering standpoint, but why does any of this actually matter to you when you're just trying to listen to your favorite morning show? Here's the bottom line. Keeping these signal shoulders under control means we can pack way more stations onto the digital radio highway without them all crashing into each other. It's what ensures you get that crystal clear, interference-free sound you expect from DAB+. It's all about using our shared airwaves efficiently, which at the end of the day just gives you a much, much better listening experience. So the next time you're flicking through channels and you're hearing that perfect, clean audio, maybe you'll think about the invisible lines on the road, working behind the scenes to keep every single signal perfectly in its lane. It's what makes the entire digital radio highway run so smoothly for all of us.